In the age of AI, the greatest risk to an enterprise isn't just the soaring cost of compute, it's the cost of being locked in. But as adoption matures, a harder question is emerging. What happens when your entire AI strategy depends on hardware you don't control? The next phase of AI won't just be about access to compute, it will be about freedom to choose. Hello, everyone. I'm your host, Wallis Mills, and this is the Modern Enterprise Unpacked. For years, as we've chased more GPUs, more scale, and bigger models, AI has been synonymous with a single hardware ecosystem. But when 4 million developers are locked into one proprietary language, while supply chains stretch to 18-month lead times, that dependency transforms from a convenience into a bottleneck. The future of the modern enterprise isn't about picking sides in a chip war. It's about the Great Decoupling, the strategic separation of your software intelligence from the silicon beneath it. Today, we're exploring that shift away from proprietary gravity and toward hardware-agnostic infrastructure. Because as demand for AI explodes, enterprises are realizing that being locked into a single vendor ecosystem isn't just expensive, it's strategically risky. Joining me today is Michael Søndergaard, CEO and co-founder of Spectral Compute. A computer scientist by training, Michael has spent over a decade optimizing accelerated compute workloads. In 2018, he identified a growing frustration that is now reaching a breaking point for the entire industry, the CUDA tax. This frustration led to the creation of Scale, a breakthrough solution that allows those 4 million CUDA developers to run their workloads natively on both NVIDIA and AMD GPUs without writing a single line of code. With a recent $6 million in seed funding and a mission to defragment the market, Michael is at the center of the movement to turn compute back into a diversified business resource rather than a fixed high-risk dependency. Thank you, Michael, for joining us here on the Modern Enterprise Unpacked.
Thanks for having me.
Yeah, that's great. And today we're talking about the Great Decoupling. And I think you, by way of Spectral and your product Scale, are going to be pretty pivotal to the way that this next chapter unfolds and the way things shift. So I'll jump right in. I want to ask you, from your vantage point, why is the era of proprietary vertical stacks where the software layer is tethered to a very specific hardware finally reaching its breaking point? And what makes that shift toward hardware agnosticism irreversible rather than just like a cyclical trend?
That's a great question. I mean, just yesterday we saw the release of yet another proprietary AI stack with Microsoft and their Maya chip accelerator and corresponding SDK that also aims to be, well, PyTorch and AI compatible. Nobody's, so far to my knowledge, gotten around to playing with it yet. But the reason why this won't fly in general for the long run, as I see it, is there are three forces converging simultaneously here. And that's what makes this, well, an irreversible trend, right? First of all, there's the demand for compute. We're in a situation where the demand has genuinely outstripped any single vendor's ability to supply it. We've got enterprises with lead times of up to 18 months waiting for GPU allocations, and that's clearly a structural bottleneck, not actually a pricing problem, right? So secondly, there's the cost of lock-in. That's changed. When GPU clusters cost hundreds of millions of dollars and AI is becoming more of a core infrastructure rather than an R&D experiment, well, financial officers start asking different questions than before. They're going to look at, well, the convenience premium of staying in one ecosystem doesn't scale linearly with this choice. It scales exponentially suddenly. And third, perhaps the most underappreciated one is the talent equation. It's shifted. There's roughly 4 million CUDA developers globally. And the sensible approach, as we see it, is just to accept that reality and instead of, well, forcing a migration away from a language and an ecosystem that has fostered that talent pool for the last 20 years, right? But simply, well, enterprises can't really afford to go without hardware and ecosystem choice any longer. So lock-in was tolerable, in the earlier days of GPU compute when they were more like a line item, but it's intolerable when they're the foundation of compute as we know it.
You're right, Michael. When you have 4 million developers locked into a single ecosystem, the talent tax becomes the biggest barrier to entry. I think for me, that's exactly where the Great Decoupling begins. It's not just a separating of software from hardware, but separating the intelligence of that talent pool that you just mentioned from the scarcity of a single vendor's silicon. You know, Michael, we often see hardware vendors disincentivized to optimize existing code bases. Instead, they prefer to push customers towards the next generation of silicon. How does this forced deprecation cycle act as the ultimate legacy constraint for the modern enterprise, in your opinion?
Precisely because we're not doing that full stack integration, we have benefits by being incentive aligned directly with the customers, where, well, getting more performance out of already deployed compute is actually something they want, right? Which isn't what the chip vendor wants. They want to sell you next year's compute, next year's chip.
All right. So, just for my audience, fundamentally, would you say that Spectral is enabling the decoupling of intelligence from infrastructure? Would you say that that's about right?
Yeah, sounds about right. I mean, it's a very general purpose. So whatever you do with compute that can be expressed with a CUDA-like programming model, well, we enable that on a diverse set of hardware is the intention.
Okay, perfect. All right. So I just wanted to level set for everybody.
Yeah.
So Spectral is enabling the decoupling of intelligence from infrastructure, and we kind of agreed that fundamentally that's what's going on here. And you mentioned it isn't a matter of NVIDIA or AMD, but it's the ability to enable both. So how does scale allow an enterprise to orchestrate workloads across a diverse GPU fleet without rewriting their entire code base? And also looking at Scale's architecture, how do you achieve performance improvements on existing NVIDIA and AMD hardware that vendors might be leaving on the table?
Yeah, so the key insight here is where we intervene in the stack. Most approaches to hardware abstraction asks you to rewrite your code in a new framework or language. And that's effectively asking you to throw away all your existing investment and bet on a new ecosystem instead. And we don't see that as de-risking. It's rather trading one lock-in for another and, well, perpetually repeating prior art. So what we do is we, at the compiler level, accept CUDA as the de facto standard source code for expressing accelerated computing. The very same code that is QA'd and runs tested in production on NVIDIA GPUs today. And then we compile it natively to run on other targets as well as NVIDIA. By the way, we haven't announced that quite yet, but it is our intention to support NVIDIA as a first-class citizen. So we don't do any emulation, and there's no inherent translation loss with this approach, because what we can do is at the compiler level, map the corresponding CUDA features to the available hardware accelerated features that exist. A popular one for AI is, of course, tensor cores, as NVIDIA call them. AMD have an equivalent one. They call them matrix cores. And largely, these features are interchangeable if approached correctly from the compiler. There's a lot of complexity involved here, but it's complexity that we're dealing with at the platform level, so the application developer doesn't need to. So we're solving this for the whole ecosystem. Often this comes up with people respond with a question about performance, where, well, sometimes there's hyper optimization for a particular GPU SKU. And well, the compiler can be very smart, and there's lots of R&D left to be done when it comes to compiler R&D for GPU architectures. As a field, it's fairly young compared to the field of compilers for CPU architectures. That is a much more developed and mature field, and there's loads more room left to do in terms of improving that. But as a matter of principle, there's no inherent performance penalty or CUDA tax, as it were, because CUDA was not designed by NVIDIA to only apply to a particular GPU architecture. They've given themselves the architectural design freedoms to improve upon their hardware over the years. And so if you compare a Volta GPU to a more recent Blackwell one, well, you'll find they've got very, very different hardware features. And they look at the transistor level nothing alike. Probably the Blackwell one looks more like an AMD recent one. So it's just an example of how we approach this.
You know, Michael, I think what's pivotal here is that it is an emulation. By compiling CUDA natively to other targets, what's special is that you, and by you I mean Spectral, are enabling enterprises to run production tested code across a diverse GPU fleet without sacrificing performance. And then that's where the real shift happens, because then compute becomes a business decision again and not a technical constraint. It sounds like there's just so much more possibility on the horizon. And I think that that's really important because NVIDIA, it just dominates the AI infrastructure market, right? You know, I think there are estimates that they hold about like 90% share of the AI, you know, data GPU
90 plus.
market. Yeah.
Yeah.
It's
With
pretty...
reason. I mean, they did a great job.
Oh, absolutely, absolutely. But 90% is a pretty, it's like you said, plus is a pretty huge percentage of a market share. And so now scale is, you know, obviously you're designing so that CUDA, for our audience, that's the programming model required for developers to use NVIDIA GPUs, hardware agnostic. So how does all of this new incredible freedom shift and empower leaders to build in ways that weren't possible 3 to 5 years ago? And how does returning the provisioning thought process to the client fundamentally change the economics of building AI at scale?
Yeah, so 3 to 5 years ago, if you were actually had one choice, and that meant every decision downstream, your cloud provider, your on-prem strategy, essentially your negotiation leverage, your disaster recovery options, everything was constrained by that one choice, that one dependency. And so what this unlocks, what changes here is when compute becomes agnostic, the provisioning becomes a business decision again, rather than a technical feat and a technical marathon in order to make it even possible. So you can run workloads, training workloads, or inference where you get the best price performance and where you have the capacity. And you can design cluster architectures for resilience rather than vendor convenience, as it were. And this economic shift is substantial. We see enterprises that have been locked into a single vendor suddenly, well, discovering they've got leverage and new supply chain options. And generally, leverage in a supply constrained market translates directly to margin.
Yes, margin. Yeah, and leverage, right? To be able to sway that whole situation in your direction as an enterprise is huge. But you know, traditionally centralization was seen as safe. So this is a paradigm shift, and because people are finding that being tethered to a single vendor's supply chain creates massive fragility. And I think we've really seen that, you know, maybe over the last year or so, as things have kind of swayed and rocked back and forth across the world. But how does scale rewrite the enterprise risk profile by transforming compute from a bottleneck into a resilient, diversified asset?
Well, that single vendor is safe assumption was always a bit of an illusion, right? It felt true because the consequences of the concentration were hidden. But as you pointed out, recent years have exposed the fragility. So when your entire AI roadmap depends on one supplier's ability to manufacture enough chips, allocate them to you rather than your other highest bidders in the market, and maintain a supply chain across multiple geopolitical pressure points, well, that's not really safety. So with scale, what we're aiming for is enterprises being able to just build an optionality first architecture. You don't have to move everything to one vendor tomorrow. You can also just not abandon all your prior investments. What you gain is the ability to flex across a diverse fleets as circumstances change. Next year, the supply chain bottleneck on one vendor might be better than it was last year, and you can suddenly price or make better purchase decisions and supply procurement decisions than you ever could before when you were supply constrained, right? So that's a shift from compute as a bottleneck to compute as resilient architecture. Your capacity planning becomes additive instead of just dependent on a single vendor's roadmap or allocation decisions.
Yeah, and I think that's going to be critical, right? Like it's no longer like it's great to have leverage. It's great, but it's no longer nice to have. Like it's become critical to be able to have that diversification.
If you're enjoying this conversation, make sure to subscribe to the Modern Enterprise Unpacked, where we break down the forces shaping AI, infrastructure, and enterprise strategy. And if your organization is navigating AI adoption, infrastructure strategy, or taking your AI-powered product to market, you can explore more at modernenterprise.ai. Now back to the conversation.
All right, you're gonna kind of switch up a little bit here and kind of move on to double clicking on the software bit. With the rise of PyTorch 2.0 and OpenAI's Triton, we're seeing real momentum toward hardware abstraction at the framework level. In your recent discussion with Jeff Tatarchik over at TensorWave, great conversation. My audience might want to go check that out. Michael has some great insights there. You shared some really sound reasoning about the software landscape and the real logic behind why CUDA isn't going anywhere soon. We totally agree. That said, NVIDIA is not known for passivity. So we've seen them restrict translation layers specifically to kill projects like SLUDA. And beyond the technical challenge of clean room reverse engineering, how do you business-proof Spectral against a behemoth that can change the legal rules of the game overnight? Specifically, if NVIDIA clarifies that output generated by their tool chains cannot be recompiled for rival chips, does your seed to silicon approach provide a safe harbor that SLUDA didn't have?
Yeah, that's exactly the right question to ask. CUDA is an interesting project. I highly recommend to look into the history of this colored one. It was originally for Intel and then for AMD, and now it's seen a new light with an open source gathering of sorts. But the fundamental approach is different than what we're taking. So SLUDA is taking the output of NVIDIA's compiler toolkit and then just in time translating that for a different architecture, which is not compatible with NVIDIA's EULA. So our approach is architecturally different in that we don't rely on the output of any other toolchain. We've built our toolchain from the ground up to be drop-in compatible with NVIDIA's toolchain, down to the name of the binaries, such that build systems just work the same way when our toolkit is underneath as when NVIDIA's is underneath. So we just have re-implemented in a clean room fashion everything necessary for this to work out of the box. We're not then in that chain generated by NVIDIA, right? So that it distances us from those EULA questions, and there's no legal question anymore when this is the approach. And this is an established standard by the Oracle v. Google case that was heard in the Supreme Court some years ago. They decided statutorily that, APIs are inherently not copyrightable. And even if they were, such copying, or it's not copying, it's there's only so many ways to define a function that adds two numbers, for instance, right? That was one of the findings. There's just a fixed amount of ways you can define that. And if you were to do this sort of thing, even if it were considered copyright infringement, this would be still considered fair use under copyright if that were applicable, but it's not. I might also add, we of course maintain ongoing legal review of our approach, but fundamentally customers of us aren't licensing anything but our toolkit when they use us, and they provide their own code that they have authored that they have rights to. So no third-party closed licenses are being violated or used in the process of applying scale to a particular CUDA program.
For my audience, this is all of this new possibility and the leverage and your ability to, kind of shore yourself up against being able to diversify in a very interesting geopolitical market. That's not going to go away overnight because of the way that you've approached this. So this is incredible. Um, you know, so you're here to stay in a polarized geopolitical landscape like we were just talking about. Does Spectral aim to remain an independent kind of like Switzerland of compute, like this neutral party that connects everyone? From what you shared with me and what I believe I saw on your site, this extensibility is intended to go beyond AMD. So what would you say is your ultimate end game?
Yeah, the Switzerland framing is useful. Our value proposition depends on not being captured by any one individual particular hardware ecosystem. In fact, we are the bridge between all of them. Just bringing CUDA compatibility to AMD is not the only thing we'd like to do. We'd like to bridge the best parts of both ecosystems. So the new frontier research that happens in AMD land on AMD and ROCm and HIP, we'd like to bring that to NVIDIA as well. Just making that switching between the ecosystems a frictionless experience. So the moment we would become a front for a single vendor or a stalking horse for another one, well, we lose this very valuable thing, which is genuine hardware agnosticism. Enterprises will trust us precisely because we're doing what we're doing and incentivizing ourselves not to optimize for any particular vendor, but for all of them independently for the future, as well as, well, past deployed hardware that may not be supported by the chip vendors themselves anymore. So in terms of end game, what we want to see is to Spectral company and scale to become the default answer to the question that most enterprises will have, which is how do we access this huge global supply of accelerated computing capabilities that are being built right now as we speak in the billions of dollars of data centers without just being locked into a slice of it based off of a single vendor's roadmap? And what innovations happen out in the space, we'd like to be able to apply all of them, right? There's no reason why frontier AI research should only happen on one vendor and then maybe 6 months later get the benefits of being computed on other vendors. And yeah, we think this is a large answer. We're not empire building, but it is an urgent question, and it's structurally important for the industry at large that somebody does this. And we don't see anybody else approaching it the way we are. Everybody else seems to be building new ecosystems, new frameworks, new languages, etc., which, well, from our perspective, doesn't bring that world that we want.
Yeah, what an incredible and important mission. Frankly, I'm optimistic about how decoupled architectures empower enterprises with real choice, especially in the mid-market. Up until now, diversifying infrastructure would have meant diversifying your workforce. Like we talked about earlier, you need a CUDA team, you need a ROCm team, and a third team maybe to bridge the two. And that's a talent tax that most, especially in the mid-market, they simply can't afford that. And all while, we talked about that allocation issue up front, trying to gain access to GPU allocations, and all that while keeping in mind the refresh cycles, right? Because then that happens too. So as enterprises move toward these decoupled architectures, what are the most meaningful shifts you expect to see in how operations and decision-making function over the next several years?
Well, the most meaningful shift, as I expected, is that compute procurement starts to look more like financial portfolio management than just traditional IT purchasing with those huge constraints on that supply chain. There are plenty of interesting startups out there who are trying to create derivatives markets based off of the availability of compute. And that whole thing as a possibility is only unlocked if compute is fungible, right? So leading back to what I was talking about before, well, somebody needs to do this. And when you can run then workloads on these multiple hardware platforms, you can optimize dynamically. You're thinking about cost curves, availability, geographic distribution, risk diversification, and your ops team starts making decisions that look more like a trading desk than traditional data center ops. And at the decision-making level, what I see is we'll have a more build versus buy versus rent calculus that's much more sophisticated than what you've got now, where it's, well, rent or wait, essentially. And again, back to the lock-in. But when you're not locked in, then you can be opportunistic. You can have things like spot capacity becoming more usable. On-prem investments become hedges instead of huge commitments. Multi-cloud stops being a compliance checkbox and starts being an actual operational strategy. And with the advent of sovereign AI and well, data security that we see globally is a trend that people want to migrate to more local data centers. Well, all this is ever more necessary.
Yeah, I like that. Opportunistic and being strategic. Isn't that just the meaning of being of enterprising, right?
Yeah.
So for our CEOs and CTOs and the rest of the C-suite listening and our leaders, what is one decisive move they can make in the near term and one longer term commitment they must be willing to make to benefit from this decoupling, but without destabilizing their organization?
Well, for the near term, conduct an honest dependency audit. Most organizations, as we see it, dramatically underestimate how deep their vendor lock-in runs. It's not just about the GPUs, it's about the libraries, the frameworks, and critically, the trained staff, the optimized pipelines you've got in production of what you're doing. Map that all out and understand what you have to do if your primary vendor doubled prices or have allocations. That clarity is valuable to you, even if you don't act on it right now. And so for the longer term commitments, start treating portability as infrastructure, not as a migration project. Build the expectation of hardware choice into your architecture from the start. And well, with scale, that doesn't mean you have to tear down everything you've invested in prior. You can keep that, and you can ensure that your future design decisions preserve your optionality. Again, retaining all those prior key message there. The organizations that will thrive on this are the ones that treat compute as a diversified resource rather than a fixed dependency. And it's a mindset shift, a choice. It's one that should pay compounding dividends as the market evolves. And as we talked on earlier, we're seeing more and more fragmentation, right? So the further this goes, the worse it gets, unless we defragment it and actually align on a single de facto standard.
It's wonderful. I love that. There's two critical ways for them to get their head in the game and to start thinking. And I love that you gave them something that they could do in the short term that would just provide clarity, while they wait to take advantage of the opportunities that the market is going to present. Michael, this conversation has been so absolutely insightful, and we look forward to seeing scale. Scale.
Thank you. Thanks for having me.
Michael, thank you for joining us and helping unpack what a more open and hardware-agnostic future could look like for enterprise AI. And thank you to everyone for listening. If today's conversation helped you see enterprise AI a little more clearly, please subscribe and share the episode with a colleague navigating the same terrain. I'm Wallis Mills, and this has been The Modern Enterprise Unpacked, where we help leaders of AI learn when, where, and how to hedge their bets. Until next time.